Okay, algebra class, this is lesson 41 and finding rates of change and slope. One thing that I really like about algebra is that you're going to get the same concepts over and over again, and hopefully a lot of you see this word slope and you remember that we've done slope before. And what is slope? Slope is basically, when we talk about lines, you're talking about the steepness of a line. For example, here's a slope of a line that is like on a ski slope. This would be the slowest. Okay, the bunny slope, the very slow slope. This would be like a medium, and this would be an expert slope. And what slope is, it's basically it's a comparison between two things. Okay, and let's go to the first example, and then that will give you a better idea of what I'm talking about. Okay, so go to the new concepts, and slope is basically rate of change. All right, so it's a rate of change that compares the change in one quantity with the change in another. For example, the speed of a car is a rate of change that compares the distance and the time traveled. So let's look at this example. Arvon leaves his house and jogs to Corey's house. Later they walk to a local pizza shop. The graph shows the distance Arvon traveled between the time he left home and when he arrived at the pizza shop. Okay, so let's take a look. All right, so this is the distance he traveled. Here's the time it took him. So when was he traveling the fastest? All right, when was he traveling the fastest? Well, he went from 0 to 1, and see how long it took him. 7 minutes. So he did a mile in 7 minutes. All right. Now here, after 7 minutes, how far did he go from 7 until 15 minutes? Well, he didn't go anywhere. He stayed at 1 mile. So he's obviously staying still there. That's probably when they were at the pizza shop. Then he went from this is minute 15. He went a half of a mile, right? He goes from 1 to 1.5, and it takes him, well, actually more than 22. So he went from like 15 to 22. All right, the time 7 minutes in a half of a mile. Okay, so when was he traveling the fastest? He was traveling the fastest here, because here it took him 7 minutes, but he went a mile. How long was he at Corey's house? Well, where was he still? Where was he not going any distance? From here to here. So 7 to about 15. So that's about 8 minutes. How can you tell? Well, I can tell because he's not going any further. He's staying still. Compare the graph during the times Arvon was jogging to Corey's, and when they were walking to the pizza shop. Okay, so he's jogging, here's walking. Well, the rate of change, I mean, he's going a lot faster here, whereas this smaller slope, he's just walking very casually. Okay. All right, so look at the first example. All right, so what we're doing here is they've chosen 2 points on the line. You see the coordinates, 1 and then up 60. Here, 2 up 120, and they're going to find the slope, and they're going to use the slope formula. Okay, so that basically with words, they're saying choose, a car travels on a highway at constant speed. The graph shows the relationship between the distance traveled and the time traveled to find the rate of change, or slope. So find the slope. You need 2 points, and basically what you're doing is they say, it's the change of distance is over the change of time, which means, okay, it's the second number, right? You have each point has 2 coordinates. You have, let's see here, see if I can, okay. Each point has 2 coordinates, so like we have 2, we have one is at 160, the other one is at 120. Okay, so what you do is you say they're doing 120 minus 60. Notice I do the bottom minus that, the second one, over 2 minus 1, and that gives me 60 over 1. So the rate of change is 60. Bingo. 60, in this case it was miles per hour. All right, So that's just the first example. Let's go ahead to the next example to get a better understanding about this. Example 2. Determining the rate of change from a table. A shop charges a fee for renting kayaks. What is the rate of change for the rental fees? Okay. Notice you just pick out 2 points. Okay. It's the same amount. It's the same increase. So it's a constant thing, right? So you're just gonna. They just pick out 2 amounts. All right, and they choose the it's like the fourth and the second. Okay, and that's what they do. They here you have okay, here you have the first. Hold on. Here you have the first point. Okay, so the first point is at 2, 3250. It's like a point on the graph, and here's the other one at 4, 6050. Okay, so you take the 6050 minus 3250. Okay, over the 4 minus 2. Alright, and that is going to get us the answer, which is 28/2. Now some people might say, is it okay if I use the 3250 first? Alright, it's okay, but if you do that, you would need to, on the bottom, you would have to choose the 2 first. You understand? You have to take it from the same point. If you're going to use the 3250 first, 3250 minus 6050, you would need to use the 2 first. 2 minus 4, and that's going to give you a negative over a negative, which then would turn into a positive. All right, there'll be more examples like that, so just wait. Okay, so now they bring in the word slope. The slope is a line of a line is a rate of change. It is equal to the ratio of the vertical change, the rise, to the horizontal change, run. That's why you've heard me say slope equals rise over run. You see the little triangles. We've done the triangles before. Rise over run. And you can see the little triangle. Okay, so determining the slope from a graph. Find the slope of each line. Okay, notice they have they've drawn the triangle for you. Okay, and there's 2 ways to do it. I teach the triangle usually to pre-algebra kids, but for you guys, you need to start being able to use the points. Okay, so it's 4, 4, 1, and we'll do both here. 4, 1, and 0, negative 1. So the 2 points, we have 4, 1, and we have 0, negative 1. Okay, let's use the formula first. So remember, start with a second, and you're going to subtract 1. Remember, the subtraction is part of the formula. And then 0 minus 4. Okay? That will give you negative 2 over negative 4. Now here's where you got to remember. If you have 2 negatives, it becomes a positive. 2 over 4. Okay? The next thing is for counting. Okay? Remember, rise. So how much did it rise? Well, this is how much it goes up. 1, 2. That's a positive number. How much did it run? Well, it ran to the right. 1, 2, 3, 4. 4 to the right. Another thing to remember is that all lines that go this way are positive slopes. They are positive. All lines that go to the left are negative slopes. Okay? So initially, I can look at this and say, okay, I need to get a positive slope. If I got that slope to be a negative number, I would say something's wrong here. And that's important that you start thinking about this. Like this one. What kind of slope is this going to be? It's off to the left. What does that mean? You're going to get a negative slope. Okay? Let's go ahead and find it. So we have the 2 points are 1, 1. And then we have 4, negative 8. Okay, it's negative 8 minus 1 over 4 minus 1. So that is negative 9 over 3, which is negative 3. And you can put the 1. I mean, a lot of times with lines, we keep that. If it's a whole number, we keep the 1 underneath it. You can see they took it off, but it's the same thing. And that's page 257. Okay. So let's go ahead and do the next example here. Okay, this is page 258. Yeah, okay, 258, and let's go up. All right, a line with a positive slope rises from left to right. A line with a negative slope falls from left to right. There are two other cases to consider, and they are horizontal and vertical lines. And yes, and these two cases a lot of times give people fits. Okay, and I'll show you how to remember this. Okay, so you have horizontal and vertical lines. Okay, so we have okay, so let's do this. So the first one is a horizontal line. I remember that it's called horizontal because it's like when someone tells you to look out on the horizon, it's out like this. That's out like that, out the horizon. So it's a horizontal line. Okay, the two points are 2, 4, and 6, 4. Okay, so we would subtract 4 minus 4. I'm taking 4 minus 4, and then 6 minus 2, which is 4 over, 4 minus 4, which is 0. That's a 0 over 4. Okay, and the other one is a vertical line. Vertical lines are straight up and down, and your points are 2, 8, and 2, 4. Okay, which is 4 minus 8 over 2 minus 2, which is negative 4 over, goodness gracious, over 0. Gosh, I did it again. 2 minus 2. 2 minus 2. Jumping ahead of myself. Okay, so which one of these? One of these is going to be 0, and one of them is going to be not possible. Okay, so how do I know? Well, you got to remember what a fraction means. 0 to 4 means, okay, what number times 4 gives me 0? Let me say that again. What number times 4 gives me 0? Well, what number, let's put it like this, little box here, times 4 gives me 0? Well, that's obvious. It is 0. So this one is 0. Okay? The other one, what number, okay, what number times 0 gives me negative 4? So what number times 0 gives me negative 4? Well, there isn't a number that makes this possible. Why? Because any number times 0 gives me 0. That's why the answer for this one is not possible, which is like a 0 with a line through it. Okay? No solution. All right, those are the two examples. There you go. Undefined. And this one is 0. Okay, this is video 1. We will continue with the next one in a few minutes.